Greetings all of you. Today I'm here to explain about the charging circuit of a vehicle. Um, Over here, this is a rotor, uh, and this one is three-phase stator windings. This one is rectifier circuit. This one is voltage regulation circuit. This one over here is electromagnet relay. This one is charging light. This is ignition switch. This one is a battery, and this one is connected to load. So how does this circuit works? First of all, when this ignition switch is turned on, current flows from this path through this coil and from this path towards this rotor, and then current come to this node. Also, we can see current has been flowing from this path too, so it flows through this resistor and comes to this point. So as we can see, the base of the transistor TR1 gets current, so it gets turned on, so it conducts, and current flows from this path and gets ground, so the circuit gets complete. Then when current flows from this coil, it gets energized and pulls this magnetic shaped bar towards left, so it joins these two terminals, and current flows from this path to the ground, so the charging lights gets turned on. So as soon as the engine starts, this charging lights gets turned off. So how does that happen? Let's see. When engine starts to rotate, it creates three-phase rotating magnetic field, because current has been flowing from this rotor, and the rotor starts to rotate, so rotating magnetic field gets created. These three-phase stator windings cause that rotating magnetic field. So according to Faraday's law of electromagnetic induction, a three-phase EMF is generated, which is passed through this rectifier unit, which converts three-phase current and voltages into single phase current and voltages. Then it sends the current and voltages to power the load, also to charge the battery. In this condition, battery is charged, so at this time battery does not provide the power to rotate this rotor, because we can see the generated EMF or current, say, flows from this point. We can see from this point towards this rotor and comes to this point. Also, current flows from this point towards this resistor and comes to this point. As similar to previous description, this TR1 conducts and gets ground, so circuit gets complete. Hence this rotor does not powered by this battery, but powered by this generated EMF. Let's see how does this happen. You can see this battery no longer provides the power to this rotor, but the generated EMF itself provides the power. And in this condition, we can see this charging light is not turned on, because there is no potential difference between this point and this point. So when there is no potential difference, current does not flow from this path, so this charging light gets turned off as soon as the generation starts. So how does voltage regulation carried out in this circuit? Let's see. So for the generation, uh, when engine rpm increases, uh, voltage generation also increases. When the generated voltage is greater than 14.5 volt, then this Zener diode conducts as the voltage 14.5 volt is greater than the Zener breakdown voltage. Uh, we know Zener diode conducts in uh, reverse biased mode too. So if we see current flows from this path and this switch is turned on at that condition, so current comes to this point. When this Zener diode conducts, current flows from this path and the base of this TR2 gets current. Also current flows from this path towards this point also. So this TR2 conducts and gets ground. So circuit gets completed. At this point this TR1 gets turned off because current flows from this path, no longer flows from this TR1. Then when TR1 gets turned off, this router does not flow current, as we can see it does not get ground. So so the circuit does not complete this time for this rotor. So when rotor does not carry current, there is no generation of the EMF in this stator. So that's how the voltage regulation occurs in this charging circuit. Let's see how does this happen. See, current no longer flows from this rotor. So hopefully you have understood this circuit. Thanks for watching. If you like this video, like, subscribe and share. Thank you.